It looks like teleportation is now possible, but not the way we want it. Quantum physics is arguably one of the most beautiful ideas in physics, but don't expect teleportation in the quantum world to resemble the one that you see in science fiction, like Star Trek, where people are transported from one place to another without ever being anywhere in between. We're talking about teleporting information, but very much in the same sense, without ever being anywhere in between. So keep watching till the end to know more about teleportation in the quantum world and its significance. The concept of teleportation might offer us effortless mobility because travel usually takes a lot of time. With teleportation, you could travel from one place to another without any cancellations, delays, or bad experiences. Most of the transportation systems that we have today are too slow, so it makes a lot of sense for us to imagine something as fast as teleportation. This is the reason why teleportation has always played a major part in several works of science fiction. The word teleportation first appeared in the writings of Charles Fort. Teleportation, according to him, is used to show objects popping up in surprising places and also might explain the sudden disappearances and reappearances of people, such as in the case of alien abduction. It's easy to understand why writers love teleportation, because this can be a tool to make objects or people appear out of nowhere or transport them to a totally different place. But is it possible in real life? Well, most of our knowledge about teleportation comes from sci-fi works. Yes, we still don't have flying cars, jetpacks, invisibility cloaks, or anything else that some of these science fiction works earlier predicted. In the past, the idea of teleportation was not taken seriously by any of the scientists because they thought it would violate the uncertainty principle of quantum mechanics, which forbids any measuring or scanning process from extracting all the information in an atom or other object. According to the uncertainty principle, the more accurately an object is scanned, the more it is disturbed by the scanning process until it reaches a point where the object's original state has been completely disrupted, still without having extracted enough information to make the perfect replica that we want. So if we cannot extract enough information from one object to make a perfect copy, teleportation might totally be impossible. A teleportation machine in theory would work, just like a fax machine, except that the teleportation machine will be working with three-dimensional objects. Today, we don't have the ability to teleport objects or people from one place to another instantaneously, but there are some cases where teleportation can actually be achieved. Yes, you heard it right. Teleportation can actually be achieved in physics labs across the world. Scientists have found a workaround using quantum mechanics. So what exactly is quantum teleportation? Well, it is a technique for transferring quantum information from a sender at a location to a receiver some distance away. To explain quantum teleportation, we need to redefine what teleportation actually means. Currently, there are three types of teleportation. You have teleportation through a wormhole or something similar. Then you have the kind of teleportation where your body is simply relocated to another place. Then you have the kind of teleportation where your molecules are disassembled, beamed somewhere else, and reassembled in the exact same order. Your body will be scanned and the information is transmitted somewhere else, and that scanned information will be used to build an entirely new body out of different materials. It looks like the scanning and reassembling type of teleportation is actually achievable, all thanks to a property of quantum mechanics known as the quantum entanglement. The teleportation that is constantly portrayed in science fiction as a means of transferring physical objects from one location to another might not be what we have here as quantum teleportation, which only transfers quantum information. For the very first time, a team of scientists and researchers were able to achieve sustained high-fidelity quantum teleportation, which is the instant transfer of qubits or quantum bits, which happens to be the basic unit of quantum information. The collaborative team, which also includes NASA's Jet Propulsion Laboratory, successfully demonstrated this sustained long-distance teleportation of qubits of photons or quanta of light with fidelity greater than 90%. The qubits were teleported to 44 kilometers or about 27 miles over a fiber optic network using state-of-the-art single photon detectors and off-the-shelf equipment. Keep in mind that quantum teleportation is just the transfer of quantum states from one location to another using quantum entanglement, where two particles in separate locations are connected by an invisible force, which Einstein referred to as spooky action at a distance. Wait, so what exactly is quantum entanglement? Well, this is something that occurs when two or more particles are forced to hold mutually exclusive states, so determining one simultaneously determines the other. If all of this sounds confusing, there's an easy way to explain this. Let's say that you're a friend and you ordered a burger from your favorite fast food joint. Now you have two burgers in very similar packaging. One of them is a cheeseburger and the other one is a classic beef burger. So you don't know which one is which. So when you open one box, you already know what is in the other box, even if it is far away from you. That's exactly the case with quantum particles. Let's say that you have two entangled particles, so knowing the state of one will automatically tell you the state of the other as well, irrespective of the distance between them. Regardless of the distance between these two particles, the encoded information shared by the entangled pair of particles can be passed between them. By sharing these quantum qubits, researchers are now hoping to create networks of quantum computers that can share information at incredible transfer speeds. But keeping this information flow stable over long distances has been quite difficult due to changes in the environment, including noise. The good news is researchers are now working on scaling up such a system, using both entanglement to send information and quantum memory to store it as well. Scientists are also working on advanced quantum technology with the development of a chip that could be scaled up and used to build the quantum simulator of the future using nanochip. This will allow them to produce enough stable photons encoded with quantum information to scale up the technology. The chip will be about 1/10 of the thickness of a human hair, and this might enable scientists to achieve quantum supremacy, where a quantum device can solve a given computational task a lot faster than the world's most powerful computer of today. Quantum entanglement is what allows qubits that are separated by incredible distances to interact with each other instantaneously. No matter how great the distance between the correlated particles are, they will remain entangled as long as they're isolated. But none of this might sound like actual teleportation, where you could send large objects or even people from one point to another, because it simply isn't. The teleportation that we know is not going to happen anytime soon, keeping the particles entangled for a long time over long distances or with objects larger than a few atoms is way beyond what our current technology is capable of. But we already have this experiment performed multiple times with small particles, and today, scientists have successfully managed to teleport various photons, electrons, and even entire molecules dozens of miles. The concept of teleportation is no alien to us, all thanks to human teleportation existing in the works of science fiction. But in real life, teleportation is only possible in the subatomic world of quantum mechanics, and not the way it is usually depicted in Hollywood. In the quantum world, things work differently. So teleportation here is all about transportation of information rather than the transportation of matter. In 2019, scientists were able to confirm that information could be passed between photons on computer chips, even when the photons were not physically linked. Today, according to new research from the University of Rochester and Purdue University, researchers now claim that teleportation may also be possible between electrons. In a study published in Nature Communications and another one in Physical Review X, researchers including John Nickel, who happens to be an assistant professor of physics at Rochester, and Andrew Jordan, who is a professor of physics at Rochester, explored new ways of creating quantum mechanical interactions between distant electrons. The research is an extremely vital step in improving quantum computing, which will in turn revolutionize technology, medicine, and science, thereby providing us with faster and more efficient processes and sensors. If you think quantum mechanics is relatively new, well, the answer is no. The topic of quantum mechanics was also discussed during a time of Albert Einstein, who ended up calling it spooky action at a distance, or quantum entanglement. The concept of teleportation is quite exciting, and if that becomes a reality, it can be a powerful tool that can be used on a daily basis in labs all around the world. Experts are also predicting that the financial sector will benefit from the quantum internet when it comes to securing online transactions. The healthcare industry, along with several public sectors, will also experience the benefits of quantum internet. In addition to providing a faster internet, quantum computing will help organizations to solve incredibly complex puzzles like supply chain management. It will also help us exchange vast amounts of data, along with carrying out large-scale experiments in astronomy, life sciences, and material discovery. Yes, we may not have the teleportation that we wanted, but you could consider this to be the very first step towards making that goal of ours a reality.